Hello everyone, myself Soumya BJ, Assistant Professor, Department of EC, SJBIT. The subject is Digital Communication. Subject code is 18EC61. I'm discussing about the Module 1 topic, Bandpass Signal to Equivalent Low Pass. Let us first understand what is communication. As we already know, communication is the transfer of information. The main purpose of communication is to transfer information from a source to a recipient via a channel or the medium. The main goal of communication is to transfer information from one point to another point. Here, the first point refers to the source, the second point refers to the recipient, and this information will be transferred either through the help of the channel or we call it as a medium. Now let us know what are the basic things that are involved in the communication system. The basic block diagram of the communication system. What are the important blocks that are involved in the communication system? In the communication system, as we know, the information is transmitted from the source to the recipient. The source will be the first block and the recipient will be the last block. In between these two, the information will be transmitted, as I mentioned, it will be transmitted through the help of the channel. So the channel will be the middle block. Now from the source to the recipient, directly it cannot be transferred through the channel. There should be something which can do the transmission. There should be something which will do the reception. So after the source, we have got a block called transmitter, and before the recipient we have got a block called receiver. So what are the important blocks that are involved in the basic communication system means, the first block will be the source. The source will generate the signal and it will give it that signal to the transmitter. The transmitter will receive the signal and it will generate the signal in a suitable form for transmission through the channel, and then the channel will receive the means it will transmit the signal to the receiver. The receiver will receive that signal, it will change that signal to the suitable form which can be accepted by the recipient. Like this, these important blocks will always be involved in the basic communication system. Apart from this, we have got many other sub blocks also that we will be discussing in the later sections. The brief description of each block is mentioned in this slide. As we know, the first one is the source block. This source block can be an analog block or a digital source block, which can generate the signal in the analog form or which can generate the signal in the digital form. Next we have transmitter. The transmitter, it consists of transducer, it consists of amplifier, modulator, oscillator, power amplifier and antenna. Like this I can call them as the sub blocks that are involved in the transmitter. In the transmitter we may have transducer, we may have amplifier, we may have modulator, we may have oscillator, we may have power antenna amplifier, as well as we will be having antenna. Now coming to the channel. The channel or the medium is the path through which the information will be transmitted. This channel may be a wired channel or a wireless channel. It may be a coaxial cable, it may be a optical fiber or a wireless in the free space. It can be transmitted. Now coming to the receiver. The receiver does the reverse operation of the transmitter. So it will also be having the antenna to receive the signal. Again here, since the signal becomes weaker as it is been transmitted through the channel, in order to amplify that signal we will be having a amplifier. Similarly, in the transmitter, modulation process will be done. So in order to get back the signal from that modulation process, we need to do the reverse process, that is demodulator, and again there will be a oscillator, a power amplifier as well as a transducer in order to convert to the suitable form. And finally, the block that is present at the last stage is the recipient, the person who receives the signal, or it may be a speaker through which we are playing our music, a computer through which we are receiving the data that is being needed. Like this, these important blocks are involved in the communication from source to recipient. Now coming to the most important thing, it means what type of information we are intended to transfer. As we come across in the source, we are transmitting a source may be generating a analog value, or it may be generating a digital value. It means it may be in the form of a continuous waveform like the voice, a data which is in the form of a ones and zeros, a video which is in the form of a analog data. Similarly, the music, it may be in the form of ones and zeros, a email which is in the form of a binary value. Like this, the type of information may be voice, data, video, music, email. Whatever information we take, actually it will be in different forms, but while doing the transmission, they will be transmitted in the form of ones and zeros, in the form of binary data. Next, coming to the types of communication system, there are many types of communication systems. For example, a public switched telephone network, which is actually able to transmit a voice, a fax, or a modem. A voice, fax, or a modem comes to the classification of public switched telephone network. Similarly, a satellite systems which can be transmitting the radio signals, TV broadcasting, cellular, computer networks like LANs, WANs, and WLANs. These are the examples that I can take for the types of communication systems. Now coming to the next concept of the communication, that is, how do I represent the information representation in the communication. The communication systems, they converts information into either electrical form or electromagnetic form, optical signals which are appropriate for the transmission medium. Means whichever signals that are appropriate for that particular medium, based on that the communication systems will convert the information. It will convert the information either to the electrical form or the electromagnetic form or the optical signals form. Now the analog systems, they convert the analog message into the signals that can propagate through the channel. Coming to the digital systems, they convert the bits, which is in the form of digits or symbols, into the signals so that they can be transmitted through the channel. Computers naturally generate information as either characters or the bits, and usually most of the information can be converted into the bits. Analog signals which are converted to bits, they are actually converted to bits by sampling and quantizing, that is analog to digital converter. By using analog to digital conversion, analog signals will be converted to the bits by using the process of sampling and quantizing. Like this, the information whatever we receive from the source, based on the transmission medium, that information will be converted into electrical, electromagnetic, or optical signals. And coming to the analog and digital systems, the analog systems, they will be having analog message that will be converted into the signals so that they can propagate through the channel. Coming to the digital systems, they will convert the bits, digits, or symbols into the signals. Bits means which in the form of digits, symbols into the signals. And computers, usually it will generate the information in terms of characters or bits, and most of the information it can be converted to the bits. And these analog signals which is actually transmitted through the medium, they will be converted to bits either by sampling or the quantization process. Now the question of discussion is, we are moving from analog communication to digital communication. The question is, why digital? Why we need to go for digital communication? Why not analog communication? The digital techniques need to be distinguished between discrete symbols, allowing regeneration versus amplification. And in the digital communication, good processing techniques are available for digital signals. Like medium only we can consider as one of the good processing technique. And in digital communication, the data compression or the source coding can be done very easily. The error correction or channel coding using A to D conversion as well is possible in digital communication. Error correction is not possible in analog communication. Similarly, equalization is possible in digital communication. The security of the information. In digital communication, the information will be secured. It will be transmitted to the receiver in a secured manner. So, we need to go for digital communication, and in digital communication we can easily mix the signals and data using the digital techniques. Like this, we have got many advantages. This is the reason why we need to go for digital communication apart from analog communication. Digital techniques need to distinguish between discrete symbols, the allowing regeneration versus amplification. Good processing techniques are available for digital signals like medium. Data compression or source coding can be easily done. Error correction or channel coding. Equalization, security, easy to mix signals and data using the digital techniques. Now let us understand how the signal will be transmitted. What happens through the channel when the signal is being when it is being transmitted through the channel. Now, from the distance 1 to distance 5, the signal has to be transmitted. The distance 1 corresponds to original pulse signal. This is our original pulse signal. Distance 5 corresponds to amplification to regenerate the pulse. Now, after reaching some distance, there will be some distortion. Again, some more distance, the signal will be some more distorted. It will be a degraded signal. After some distance 4, the signal will be badly degraded. So, that is why in the basic block diagram of the communication system, at the transmitter as well as at the receiver, we are supposed to use the amplifier. Such degraded signal will be amplified in order to get the regenerated pulse which was present at the distance 1, which we called as original pulse signal. This was the signal which was actually taken at the transmitter part as the output. Okay, this signal at some distance, a small distance, was the original pulse signal, but after reaching some more distance it got distorted, and after reaching some more distance it became degraded gradually. Finally, it became badly degraded. So, at distance 5, we will be using a amplifier in order to regenerate that original pulse signal which is being transmitted from the distance 1. This is how we need to get back the original signal by means of amplification. Now, I discussed only about the basic block diagram of the communication system. Let us know what are the blocks that I can include in a typical digital communication system. This is the block diagram of a typical digital communication system. Now, coming to this, as you can see here, this is the place where the information source is being generated. Information source is generated. This will be given to the format. From the format, we are getting a message signals or the digital input. The information that is being taken from the information source, it will be converted into the format which is acceptable for the digital communication. The format is a digital input. So, by using the analog to digital converter, we will be converting that value into a digital input or the message symbols. Then we will give that to the source encode in order to encode that information properly. Next, we will give to that encrypt block. In order to safeguard my information, I need to use the encryption here. Next, before giving that to the channel, I need to do the channel encoding. After doing the channel encoding, I will call those output of the channel encoding as channel symbols. After that, we need to multiplex that signal. It means here it is many other signals will be transmitted through the same channel. So, from other sources, some other signals will be coming. I need to make use of the bandwidth properly. I need to utilize the bandwidth in an efficient manner. So I will multiplex those symbols that are been coming from this path with other signals that are coming from other sources using multiplexing. Next, that will be given to the pulse modulate. Pulse modulate. Next, from the pulse modulate, we give the signal to the. Next, we have band pass modulate. Next, frequency spread. Next, multiple access. From that, we are giving the signal to the channel. Next, from the channel, again multiple access. Again, frequencies despread. Next, demodulate and sample, detect, demultiplex block, channel decode, decrypt, source decode, and finally the format. As you can see in this block diagram, in the receiver section, we are doing the reverse process. Means whenever source encode is there, we are doing source decode. Wherever encrypt is there, we are doing decrypt. Wherever channel encode is there, we are doing channel decode. Multiplex, we are doing demultiplex in order to send other signals to their destinations. Next, we have got frequency despread. Again, multiple access technique has to be followed as usual. Pulse modulation is done, so we are doing detection here. Band pass modulate is been done, so we are doing demodulate and sample. Like that, the reverse process will be involved in the receiver section. This is about the block diagram of typical digital communication system. Thank you. Thank you.